If you're following along in the slides, you'll notice that I have skipped an example. I just figured it would be more beneficial to do a complicated completing the square example again, as oftentimes that's what people find really challenging in this section. And so I'll leave that one as just a practice exercise for you. Okay, so taking a look at this, there are no instructions, but we just are going to ask all the things, find all the information, and graph this thing to the best of our ability. So we're going to complete the square twice here. And to do that, as I go, I'm going to do the x's in blue and the y's in red. And we're going to do it all kind of in one fell swoop here. So the first thing we're going to do is we're going to make room here. And so 4x squared minus 24x plus whatever we're going to add in terms of the x. I guess we should do that in blue. We'll come back for that. Leave yourself a little bit of room. Plus 9y squared minus 54y. Leave yourself a little bit of room to add the y guy. Equals, let's kick that 81 over to the other side, negative 81. All right, so now we're going to add something for the x's in blue. So whatever we do to one side, we have to do to the other. We'll add it to the right side as well. Similarly, we'll add a number for the y expressions on both sides as well. So we've made room, but now we have a problem. We need to have the coefficient of 1 in front of our variable guy. So for both of these, we'll have to factor out a number. So for my x's, I'll factor out the 4 to get x squared minus 8x plus my blank. For the y's, I'll factor out 9 to get y squared minus, I think it's 6. Yep. Equals negative 81, and plus my blanks, and plus my blanks. All right, so now we do the b over 2 calculations. B is equal to negative 8, so b over 2 squared is equal to negative 8 squared. Negative 8 divided by 2 is 4. Don't let me go any further. None of that's right. Since I have an eraser here, I can fix this. And I haven't used green. Since it's a mistake, I'll go ahead and fix it in green. So, yeah, you factor 4 out of 24, you get 6. You don't get 8. Luckily, we caught that in time. Now, b is equal to negative 6. So b over 2 squared is equal to negative 6 squared. Negative 6 over 2 squared. Negative 6 over 2 is 3. Negative 3 squared gives us 9. So we're going to put a 9 here. Now, what number are we actually going to multiply on the right? Well, since it's in the parentheses, the number really being added together is 4 times 9 gives us 36. And so that's what we're going to add over here. Okay, now similarly for our y expression, again, y is equal to negative 6. Oh, that was convenient. So we can just copy the same math that we just did. We're going to get a 9 in here. But what are we actually adding? This time it's 9 times 9. So 9 times 9 is 81. We're actually adding an 81 to the left-hand side of our equals sign. So now we get nice expressions that should factor. And sure enough, they do. 4 times what times what? Well, x and x. Multiplies to 9, adds to 6, 3 and 3. Negative, negative gives us all the correct signs. Plus 9. What multiplies to 6 and adds to, multiplies to 9 and adds to 6? Well, 3 and 3 again. Similarly, they're actually the very similar problems. They just have a different variable. All right, we did a bit of math here in the background. Hey, you got a positive 81 and a negative 81. We may as well just cheat. We don't even need a calculator for that. We got 36 left. And so what do we have? We have 4 times x minus 3 quantity squared plus 9 times y minus 3 quantity squared equals 36. And to make 1, we need to set this thing equal to 1. Divide by 36 to get equal to 1. We'll divide by 36. It's really multiplying everything by 1 over 36. And we'll do some reducing as we go. Conveniently, that becomes 1. That was the goal. 9 goes into 36, something like the neighborhood of 4 times, I want to say. and 4 goes into 36 something like 9 times. So we get x minus 3 quantity squared over 9 plus y minus 3 quantity squared over 4. All right, so we found our general equation. Next thing to do is to start to identify some of the things about this. Well, we've got that a squared equals 9. That means a is equal to 3. We also know that this thing is longer in the horizontal direction because 9 is bigger than 4. So that'll help us. And then b squared is equal to 4. Well, b is equal to 2 there. And we can also directly identify the center because we have it in the correct format. So it's at 3, 3. And be careful of your signs there. It's x minus h. So x minus h compared to x minus 3, h is 3. We're going to need a little bit of room here to calculate the missing, I'm going to call it a parameter, calculate the missing value of c. Okay, so let's draw what we know so far. Real quick picture, we have a center at 3, 3, and we know we've got our center, and it's horizontal, so the focus is going to be in the horizontal direction. So the center to the focus, that's your c value, that's what we're looking to find. Now the vertical value is the short value, so we know that to our minor vertex is vertical, that's going to be our b value. Instead, that's 2. We figure that one out. And then the distance between the minor vertex and the focus is always the same as the distance between the center and the major vertex. Our a value in the horizontal direction, a equals 3. So our Pythagorean theorem here is c is equal to the hypotenuse squared, 3 squared, minus the leg squared, 2 squared. 9 minus 4 gives us root 5 again, which again is about 2.2. I think I said 2.24 last time. We're going with 2.2 this time. Whew. I know a lot of that's written on this one slide, but I'm out of room, so we're going to move to the next slide, but we're going to not rewrite that information. We're just going to recklessly use it. So, okay, I'm going to tell you that this thing is pretty well done by just working in the first quadrant. We're going to go 6 in the x direction, 1, 2, 3, 4, 5, 6. And again, always try and be reasonably accurate. 1, 2, 3, 4, 5 in the y direction. 1, 2, 3, 4, 5. It would be rude to not at least write a little bit here. We know our center is at 3, 3. We know a is equal to 3, b is equal to 2, and c is equal to root 5, which is about 2.2. Now we can just attack this from scratch. Pretend I don't know anything. First, plot your center. 3, 3, right about here. Since that's the center, you can also plot your major and minor axes. Major in the horizontal direction, going to be longer. Okay, so a is equal to 3. Well, this is 3. That's useful. 3 labeling these. That means we're going to go 3 in the direction and get to a is equal to 3, and a is equal to 3 here. That's going to go to our major vertices. So we'll put a v sub m by those. V sub m for introducing new notation on the last example, vertex sub major. You can't use it on the other one because minor, they both start with m, but it's cool. All right, minor vertices. We got to go 2 in either direction. So for minor, we go down b equals 2, and up b equals 2 from our center. So those are all convenient. All of these are landing. Vertex, vertex. You don't get subscripts because you're a minor. And now we have to put in our pesky foci. And our foci are an odd distance. They are 2 from the center in the direction. We're going to travel root 5. In this case, we're going a negative root 5 in the negative direction. So negative 2.2-ish in both directions. Oops, too far. Got carried away. And now we're going to go positive 2.2 plus root 5 is about 2.2. And that helps me see that I can just slap my foci on the major axis. Draw your vertex, not vertex, all time. I've been calling an ellipse vertex in my head. Draw your ellipse, and that's pretty good. We could summarize all these points now. The minor vertex is 3, 5. The other minor vertex is 3, 1. The major vertex is 6, 3. The other major vertex is 0, 3. The center is 3, 3. And now the focus. All right, so which part stays the same? The y stays the same, right? Because we're changing the x value here in the horizontal. And so what did we start with? Well, we start at the center, and the center is 3. So 3, oh no, that's a fat pen. And what do we do there? We start at 3, and then we travel in the correct direction, the appropriate distance of c. So 3 plus root 5 for the right one, and 3 minus root 5 for the left one. And that is it for ellipses.